Graphing inequalities. So today we're going to use what you know about one-step equations and inequalities, and we're going to pull them together. So we're going to take a look at this first one here, which is a over 3 is less than 3. And I've written it over here on this piece of paper. And I want you to consider what we might do if it was simply an equation. So if I asked you to solve this, you would say, what operation is happening to my variable? And you would say division. And we undo division with multiplication. So you'd multiply both sides by 3. And you would find out that A was equal to 9. We're going to do the same exact process here with this inequality. We're going to undo that division with multiplication. And we're going to have A, and this sign is going to stay exactly as it is. And what this is, the difference between these two is that this is an equation, so the only solution it has is 9. So if we were going to graph it on a number line, we would have 9 and 10 and 8. This would be the only point that would be included in the solution set, and that's why it's a closed circle. And this one here, this one is saying your marker number is 9. This is an open circle at the marker number. This says all numbers less than 9. It's not including 9. So this would be thickened this way. Okay? So I'm going to show you how to do that right here. I'm going to have to make it smaller. So I'm going to go to the 9. It's going to have to be open circle, and it's going to go all the way to the left. Okay, and then we're just going to continue to apply the same thought here. This is multiplication, so I'll undo it with division. I'm going to divide this by 3 and this by 3. So let's look over here. So we're going to have 3a is less than 6. And we're just applying the same exact properties that you have used in the past with equations to our inequalities. And that means that all values that are at 2 exclusively, meaning it doesn't include that point. This is all values less than 2. So that is the 2. Oops. And then we're going to go all the way out to here. Okay. So we're going to continue to do this, and hopefully you can see in this case, we would divide both sides by 4, which would make this r is greater than 2, and that's exclusive. So we would end up going all the way to the right. And you can always test a point. Like if I put 3 in here at r, 12 would be greater than 8. If I put 0 in here, 0 is not greater than 8. So you can always substitute in a number if you really want to confirm. Now this one's nice and easy because you're going to undo addition with subtraction. So we'll take a quick little look over here, and you'll see t plus 7 is greater than 8. So we're going to have t is greater than 1. That's exclusive. That's an open circle. So we're going to go to the 1, open it up. All numbers that are greater are to the right. Okay, hopefully you guys are starting to pick up on this. This one will be inclusive. You see how the equal to piece is there? So we'll divide both sides by 4, and we're going to be left with q is less than or equal to 2. So I'm going to keep that solid, and that's all numbers that are less than or equal to 2. In this case here, you can see we want to isolate the r, so we're going to add 7 to both sides. Once we do that, we'll have r, I'll show you over here, r is less than or equal to 8. So we'll have a closed circle in this one. So it's going to be at the 8, and it's all numbers that are less than, goes all the way out to here. Okay, undo division with multiplication to multiply both sides by 2. That leaves you with 2 is greater than or equal to 6. So it's going to be solid, and it's going to be greater. In this case here, we'll divide both sides by 8, so w will be less than 2. Open circle, all values to the left. Subtracting 4 from both sides, y will be less than, or all numbers will be less than, -4. and that's exclusive. All numbers to the left. Okay, so hopefully you're picking up on this. You're going to undo division with multiplication. So if you multiply this side by 2, you just get V. If you multiply this side by 2, you get 4. So all values that are less than 4. So we're going to be, sorry if it's not zoomed in correctly, it misunderstands. Okay. So at the 4, open circle, all numbers that are less than 4. Okay, so I'm just going to start to pick up my pace here a little bit. Hopefully you guys will see that. All values that are less than 4. Okay, we're going to divide both sides by 10. This is inclusive at the -1. All values that are less than or equal to -1. I'm going to divide both sides here by 9. So all values that are equal to or less than -2. I'm going to add, so actually subtract 7 from both sides here. And it's going to be inclusive. So all values that are greater than or equal to, and this will now be -2. Greater than or equal to is over here. Okay, dividing both sides here by 3. You will have all values that are less than or equal to 4. And you can continue on this way, subtracting 15 from both sides. You have a 1. All values that will be greater than, that's exclusive because there's no equal to piece. Okay, so you can continue to get up to 85. And then what will start to happen is this new idea comes into place where we have to make a slight change. So I'm going to stop here and then I'll show you that on the next video.